So, yeah, what is an outbreak? Today we are looking at an outbreak investigation. So the question should be, what is an outbreak? And why should we investigate an outbreak? Madam Bridget, what is an outbreak? Anyone to try?
Good morning, sir.
Good morning. Thank you.
Can you repeat the question?
The question is, what is an outbreak and why should we investigate an outbreak?
Okay. An outbreak is a disease that is being contracted at a very fast rate from one person to another.
Okay. A disease that is being contracted from one person at a faster rate. Okay. What about others?
So it's a disease which shows a sudden increase in a specific area or a rise which may have the potential of spreading at a fast rate.
Okay, great. Yeah. Then why should we investigate this outbreak now? Because they want to look at outbreak investigation. So why should we investigate the outbreak? So from the definition they have given, uh, we must have unexpected, okay, cases that occur usually, okay, unexpected case. So we find that maybe this is the disease that is occurring. These are cases. The way they are coming may be different months. Then you find that one month this case sharply increase. Okay, so this increase that we have seen tells us that there is a problem in this population of sin. So I've made this one to demonstrate an outbreak. So during this period here, when we have a sharp increase or excess number of cases than what we usually expect, it shows that there is a problem here. Okay, this is an outbreak. So we have the usual number of cases, then we have the increase. That is an outbreak. So today we want to look at outbreak investigation. So when outbreak occurs, it needs to be investigated. So this outbreak, the increase, it can be occur in a specific given area at among a specific group of people and among over a particular period of time. So an outbreak can be the increase in or excess increase in the cases that is reported uh, in a specific area, okay, at a given period of time and among a certain group of people. Okay, so I'm trying to admit, yeah, so that is an outbreak. Okay, So this is same as what I was just demonstrating to show the sharp increase in the cases, so that this is an outbreak. Okay. Then according to the World Health Organization, also they have given a similar definition of an outbreak for food and waterborne outbreak, which there should be two or more persons with similar illness, okay, after ingestion of the same type of food or water from the same source. So this shows that an outbreak, there should be a similar cause, okay, and similar disease that is happening, okay. So according to the epidemiological evidence, the food or water is the source of the illness, okay. So now, why investigate an outbreak? We want to investigate an outbreak because we want to stop the outbreak. Have seen that sharp increase in the cases of a particular disease at a specific time. So when we are doing an investigation, we want to find out what is causing this increase or this excess increase in cases, so that we find preventive measures to stop the outbreak. So we want to find the source of that outbreak and stop it. And we also want to prevent the future outbreak. Yeah, we want to prevent the future outbreak and improve the surveillance and outbreak detection. So in terms of surveillance is the monitoring, okay, a systematic monitoring of diseases in the community. So we want to make sure that we strengthen surveillance, so that we improve outbreak detection, because surveillance monitor what is happening in the community, and when there is any change through surveillance system, we can be able to know that there is a problem somewhere. And we also want to improve our knowledge of what is happening in the community and keep the public's confidence, because the public will know that we have people that are working, that are competent, and that can help us to prevent the disease. Then we use the same knowledge to improve training of people. Yeah. Then this outbreak can mostly, it involves a retrospective investigation. Okay, mostly of outbreak are retrospective, in the sense that when a disease happens or when an outbreak happens, we have to go back to follow up the exposure. We want to go back in the past to look for exposure. Okay, so you find that we have diseases or that happened maybe 2 weeks ago, 1 week ago, days ago, or months ago. Then when we start an investigation, we want to trace those people. Where were they coming from? Okay, and what happened? So we have cases and want to go back in the future, to in the past, to correct the data on what happened. Okay, that is a retrospective investigation. Okay. So now, what will help us to understand what happened, or the cause, the source of an outbreak, is through us understanding the epidemiological triangle, which is the epidemiological triad, which we looked at last time. So for any disease that happens, there are factors that are involved to facilitate that disease to happen. And we looked at these factors last time. We said there should be an agent, which is the cause of the disease. Then there is a host, which is the person or an organism which is affected. Then we have the environment, which constitute of uh, conditions, okay, that's favorable for the disease to happen, or not for favorable for the disease to happen. Then there's time. Okay, today we introduce the issue of time. At what time? Maybe it could be seasons when this disease happens, when the maybe when the environment become conducive for the agent to thrive. As we know, for mosquitoes, they usually thrive during the rain season, and even the bacteria for cholera also thrive during the rain season, because at that time you find that there's a lot of water and there's poor sanitation. So these organisms are going to survive. So this epidemiological triangle, it shows, okay, the interaction in the environment, which create the favorable conditions for the disease to happen. Okay, so for an outbreak to happen in a population, it usually involves several factors, okay, which include main people, it includes objects and avenues of transmission, and an organism, okay, that can be involved in the spread of disease. So this triangle, it was developed to help simplify, explain the factors that can help to cause disease, and also to help to explain how we can prevent disease. So it is argued that if we break one leg of this triangle, okay, if we break one leg of this triangle, we can end the outbreak. For instance, if we if we break the agent, okay, to the host, that means we remove transmission here. We put in preventive measures, okay, we put in preventive measures to prevent the transmission or the interaction between the agent and the host. Then we are going to prevent the occurrence of the outbreak. Okay, this one here, let me come to this one. Okay, yeah, so we have where we can break this environment to the host, where maybe we use hand washing, and we use chlorine, okay, for water. We treat water with chlorine, and we eat safe food. We handle food in a safe manner. That means we are disrupting the environment in which the bacteria can thrive or can be transmitted to the host. Okay, then there is host agent. So to prevent this host uh, interacting the agent, we can immunize people. Okay, we can isolate people and treat them. Then we are interrupting the host agent reg there. Then we have agent to the environment, okay, where we do in the environment, we do insect and vector control. We have seen there are those things that people, maybe from council, they come, they are spraying in the community. They do life siding. All those things are trying to control the environment in which the microorganism can thrive. So we need to look at the steps of an outbreak investigation. Any question so far?
Sir, kindly go back to the previous slide.
This one?
Yes, yes, that one. Yes.
Mm-hmm.
Kindly explain on the host and the agent again.
Host and agent. This one?
Yes, yes.
Okay. So this is you remember our triangle? We have an agent and the host. So we want to prevent the interaction between the host and the agent. Who is the host first?
A human being.
A human being. An agent?
It should be a bacteria or a virus.
Yeah, a bacteria or a virus.
A
So
virus.
first, we want to, the first thing, you want to strengthen this host first, okay? You want to make this host resistant to this agent, okay? Maybe through the immune system. So you want to strengthen the immune system of this host. So you can vaccinate the host. That means this agent will not be able to fight the what? The host. That's where immunization is coming in and vaccination. Okay? And also to prevent this host from coming into contact with the agent, you can do what? We can do isolation. Okay? Where you isolate those people that are infected, or you isolate the source of the infection. Okay? Then the other thing, we need to treat the host. So this host, as you know, a person can be infectious. Now, to make that person uh, uh, free from this disease and not be able to transmit it to other people, we need to treat this host. Okay? To reduce the infectiousness period, we need to treat those people that are infected. Then the agent will not be able to spread to other people. Is it clear?
Yes, sir. Thank you.
Okay. So the steps for outbreak investigation. So first, when you hear that there is an outbreak, okay, the first step is to verify. Okay, you verify the outbreak, you confirm. So sometimes you find people maybe from the district health office, when they hear that, oh, there is an outbreak this side, if it has a certain health facility, they'll make a follow up, okay, to ask if there is indeed an outbreak there. They are going to confirm the cases and define the cases. Who are people that is there a case here of this disease, and is there an access of these cases? Because sometimes you find that the disease is already there in the community, and maybe it just these days with the social media, people like alarming other people even when it is not an outbreak. So we need to go and confirm that an outbreak is there. After we have confirmed, we need to describe that outbreak. You would describe the outbreak by person who is affected, okay, and the place where is this outbreak happening and time. At what time is the outbreak happening? Is it the rain season? Is it during the hot season? Is it just a certain month? Where exactly? Okay, so we want to know these parameters so that we can help to trace the outbreak. After we have known the person who is involved or people who are affected in the place where this is happening from and the time, we need now to formulate a hypothesis. Okay, what is a hypothesis? What is a hypothesis?
A hypothesis is a predictive statement that describes the relationship between variables.
Yes, so a hypothesis is a statement that describes the relationship between variable, or a statement that explain how things happen and why they happen. So now a hypothesis is not a scientific statement. Okay? A hypothesis is not a scientific statement. It's non-proven. Okay? Then when we do the study, when we test this hypothesis and the results come out, that's when it become a scientific. And when it become a scientific statement, now it become a theory. Okay, what is a theory? What is a theory? So a theory is just an opposite of a hypothesis, not an opposite, but a scientifically proven, okay, statement which describe the relationship between variables. Before it is scientifically proven, then it is a hypothesis. So after you have detected and known where the disease is happening, you need to develop a hypothesis to explain the relationship between the variable, which include the agent, the host, and uh, the environment. So for instance, if you have an outbreak of cholera in Lusaka, you need to look at the agent. Okay, what is causing this? You need to come up with um, an agent. Then the host who is being affected in the environment. You look at the conditions that are favorable for cholera outbreak to happen. Once you develop the hypothesis, now you need to test. Okay, you need to test the hypothesis. That's where now you gather information. Okay, you ask people, you read articles, you do interviews to know what is happening in the community. After that, you can plan and execute additional studies like the case studies, the cohort studies, and so on. Then you need to, from the findings, using the findings, you need to develop intervention or control measures, because the aim of the outbreak investigation is to end the outbreak. So you need now to implement this control measure and find ways on how you can evaluate them to know their effectiveness. So you need to communicate. After that, you need to communicate the findings. What have you found out? Communicate to the stakeholders, to people who are involved in outbreak investigation, and even people that are affected. Okay, so these are the steps for outbreak investigation, and what we are going to do now, we just look at each in details. Yeah. So these steps may occur simultaneously or be repeated as new information is uh, being received. So when this outbreak has happened, you can start doing these steps simultaneously. So that means you can do more than one step at a time. Okay, because when an outbreak happens, there is no time to wait. There is an emergency, so people have to wake. Even at night, people will be waking, okay, to make sure that you control the outbreak. So the first step was verification. So how do you do verification? You have to do it through laboratory testing. Okay, this is the valid method of confirming the outbreak. We need to do laboratory testing and rule out misdiagnosis or laboratory errors. You remember last time we were looking at the false negative, we are looking at true negative, and so on. So you need to rule out those that are due to errors. You need to remove them so that you have correct information. So yeah, that is the gist. Then we say number two, you need to define this case. Okay, on the same laboratory, on the same case verification, you need to define a case and conduct case defining laboratory test. So you need to look at the symptoms or laboratory result. Okay, you look at the symptoms, then you need to look at the time period. What is the time when this outbreak is happening and location. Okay, then conduct surveillance. Okay, using case definition, you need to look at the existing surveillance. What are the existing surveillance monitoring system? What are they saying? Then active surveillance, where you do now more study to review medical records to see if there is a change, because the medical records will show the trends. Okay, will show the trends. So it's more like it. Um, if you review the medical record, let me do this. At each health facility, there are records for each disease. Okay? There are records for each disease. That's the way they are doing. So these records, they are given at a particular time. So you have this one, and you have maybe different months. So when you are doing a record, it will show you the changes of the disease in particular months. So you know that maybe the case of malaria during January are high and they reduce in February. They become high maybe in July, September, and they reduce over time. So you see the medical record. It will show the trend of disease in the area. Okay, and it will show you what time uh, the disease may be increase or decrease in a certain given area. Then you need also to interview the patients to find out what is happening. Okay, they will give you information. Any question? Are we together?
Yes.
Yeah. Then you look at the place where this disease is happening from. Where were they infected from? Okay, so look at where did the people eat in the last, if it's an foodborne disease, okay, or food poison, you need to look at where did these people eat the food. Okay, in the last 12 hours, 24 hours, 48 hours, and 72 hours. You need to know where did these people eat, so that you can trace back where these people are coming from. You look at the environment. Okay, you look at water flows, or where do they get the water to drink. You look at the wind direction, because you know that all these things can affect people. The traffic patterns, how are people moving in this community, it will tell you uh, where the problem is. Then you need to consider place different from perspective. So you look at the place, maybe where these people may be affected from home, or is it from workplace, or is it from school or church. So you find that some outbreak, maybe the source is at church. Maybe there was a certain church member who took maybe contaminated food there, or food that has poison, and people eat, they become sick. Maybe it's at school, because of maybe poor sanitation at school, and school children start becoming sick. So you need to look at all these factors when you are looking at place. Okay, so you need to know where are the people coming from, which place. Okay, so depending on the type of infection that is there, or outbreak that is there, if it's a food poison, you need to look at where people ate this food from. Okay, when you look at time, you need to know the time, the seasons. Okay, and also you need to create an epidemic curve for each person who became ill. You collect information on when symptoms first began. Okay, on each person who becomes sick, you need to know uh, when symptoms started, so that you can know the incubation period. Okay, from the time maybe of contact to maybe the time that they ate the food, and the time when the symptoms started, it will tell you the incubation period. And when you know the incubation period, you'll be able now to go and study which agent has this incubation period. Okay, are we together? Hello. Okay.
Yes, sir.
Great. So
Yes, we're together.
I want us to finish this slide. That's why I'm moving fast today. So you look at the incubation period. We have already said the incubation period is very important because it will tell you or it will help you to identify the organism that is involved, the microorganism that involved. As we know, different microorganisms have different um, incubation period. Okay, so each infectious disease has a characteristics incubation period, just like we have said. So you have to look at the dosage of the infectious agent, the port of entry, and the immune response of the host. Okay, so because of the interplay of these factors, incubation period will vary among individuals. So depending on the dosage of the infectious agent. So dosage means the number of infectious agents that the person come into contact, because for the disease to happen, um, there should be a number. Okay, or first the agent have to multiply to a certain number which is able to cause the disease. Then also the port of entry can affect the incubation period, because we find that if the disease enter through the mouth, if the bacteria enter through the mouth, maybe it goes it has to go to the stomach. Okay, it will take time maybe for it to reach there and to reach at the place where it's going to cause an infection where it can thrive. It will take a bit time, but if it enter direct, maybe someone has an injury and the disease, the bacteria enter direct, goes to the stomach directly, the incubation period there will be shortened. So uh, depending on the port of entry and also the immune response of the host, because you find that maybe the bacteria is trying to multiply and the immune system is fighting back, so it's delaying that multiplication of the agent in the host, so it will affect the incubation period. So you need to understand all those dynamics. Okay, then as you are describing this outbreak, okay, there are different types of outbreak. Okay, and usually they are grouped into two classes. There is common source outbreak and propagated source outbreak. So common source outbreak is just one single source where all the cases are getting infected from. Then propagated outbreak involves person to person transmission. Okay, person to person transmission. Then under this common source we have a point outbreak, we have intermittent outbreak and the continuous outbreak. So we'll see this one. Okay, we'll see this one. Okay, so look at common source outbreak. So a common source outbreak, here the cases of disease arise from a single, okay, the keyword here is a single or shared common source, such as a batch of bad food, okay, industrial pollution, or contaminated water supply. Okay, controlling the source. So controlling the source can help to stop the outbreak. So under common source, you are going to have a single uh, source. Okay, a single source of an outbreak where people are getting the infection. Maybe it's contaminated water from a river. So anyone who gets this water, who drinks this water, will become sick. So now, under this one, under common source, we have other types of an outbreak. We have a single point outbreak. So when we are talking about a single point outbreak, this is an outbreak that occurs at a specific short period of time. Okay, it occur at a specific time, like we can see from this uh, this figure here. It occur within one incubation period, suggesting that the cases did not arise from person to person spread. Okay, the fact that the outbreak was of short duration suggests that it was a single brief hence point. So in this outbreak, it almost have the same incubation period. Maybe we can say maybe people are exposed, maybe they eat food. Okay, they eat a food which is contaminated. So you find that if the incubation period is 7 days, after 7 days you are going to see a sharp increase, okay, in the cases. You're going to have main cases, and after the duration of that disease, you see again a sharp decrease, like we can see here. We can see a sharp increase and a sharp decrease after some days. So this become a single point outbreak. Okay, then we have continuous outbreak. Continuous outbreak. So this one is now in terms of time also. So a continuous outbreak, you find that after people become sick, maybe this is usually maybe due to contaminated water. People continue drinking that contaminated water, and the cases continues. Okay, the cases remain high because you are controlling. Maybe you are just treating people, then you are not controlling the source where they are getting water. So the case will continue. Okay, so this shows maybe uncontrolled problem in the community that make the problem to continue. Okay, then we have intermittent outbreak. Okay, which happens over time, but it happens and it stops, it happens and it stops repeatedly. So this is a repeatedly outbreak where it can happen. Maybe you have an outbreak in June, again you have an outbreak in May, you have an outbreak in September, you have an outbreak in November. So it keeps on coming because maybe you have not addressed the problem, or maybe it can be seasonal, like the way we have in Zambia. We have cholera every rain season. We have cholera every rain season. We have cholera. So that cholera that we have is intermittent because it just come and it does not go for good. It will come back. It does not continue after the rain season. It just is actually a peak time when we have too much rain. There is flood. That's when you see it coming. After that period again, you find that it disappears. It will come back again when the conditions are favorable. Okay. Any question on this type of outbreak? The,
Good morning, sir.
good morning. Thanks.
Kindly repeat on the point. I didn't really understand.
Okay, on the point outbreak. So point means specific time. Let's take for instance, we have these people uh, maybe who eat the food. Okay, they go to the wedding, they eat food. After eating food, maybe the incubation period will take maybe 7 days. So after 7 days, you are going to experience a sharp increase. Okay, a sharp increase in the cases. Now, depending on the duration of disease, because you have those acute diseases which takes maybe few days. Okay, if the disease maybe it takes 4 days, then the person would die or get recovered. So you have the sharp increase in 4 days. You will not have any other additional cases. It will just for that period of time. Once those people are cleared, the the outbreak would do what? Would decrease again. So because it happens at a specific, just at a certain point in time, thus it becomes a point outbreak. Okay, it becomes a point outbreak because it just happened at a specific time. And after that time it reduces. So this one can be due to poisoning. Yeah, poisoning, especially food poisoning, because the source is the same. Number one, you have to know that the source is the same where these people get this infection, and the the duration or the incubation period is also the same, and the duration of disease is also the same. So after this period, the disease will go down again. Okay, that is point outbreak, and there is no transmission to other people. Then you find another type of outbreak. Maybe let me now take you to the water, contaminated water. People will continue drinking this water and they'll continue being affected. So we're going to have a continuous outbreak, which will happen over a period of time as long as this source is not controlled. Until you control this source, that's when you see the decrease in the number of cases. Okay? Then intermittent, it will just happen when the conditions are favorable. Okay, like we see in case of cholera, it will just happen at a specific period, at a specific time when the conditions are favorable. So this one can be a season outbreaks, like we have cholera in Zambia. Is the difference clear now?
Yes, sir. Thank you.
Okay, wonderful. Then we have this propagated outbreak, which is the type of outbreak which spread from person to person. So we can have this person who come into contact with an agent somewhere, and this person will transmit the disease to another person. This other person also become the source of infection for other people, and these other people they also become source of infection for these other people. So in this case, how can you control this type of an outbreak?
Maybe by isolating the infected people.
Yes. So when you see this type of an outbreak, you have to do what? You have to isolate these infected people. They should not come into contact with other people. So you do isolation. So depending on the type of the outbreak, it can help you to determine uh, the the effective control measures. Okay. So that is the person to person outbreak, or yeah. So you continue with now describing the outbreak, the person who is infected. You also need to know who is infected. You have looked at the place, which include where these people coming from and the time. Okay, then the person who is infected. So you need to evaluate uh, uh, the characteristics of people who are infected. Okay, what do these cases have in common? You have to look at children versus adults. Does the disease affect the children or does it affect only adults? Have to look at male and female characteristics. Okay. the behaviors. Maybe you find that those people like which disease this one which affect children who are swimming. What's that disease? Bioharzia. Yes. Yeah, bioharzia. So you find that maybe it only affects children who are swimming, and you know that okay, I have to follow up. Where do they swim from? Okay, maybe you look at the diet as well. Okay, so you need to understand those characteristics. Then you look at the attack rate in each population or for each group of people. Okay, for instance, you look at the attack rate in females. What is the risk of being attacked among females? And you also look at the attack rate maybe for those people who maybe were exposed to a certain risk factor. You compare with people that were not exposed. So here we have, you can look at the number of people who drank milk, okay, over the total number of people, the ill people who drank milk over the total number of people who drank milk. So you need to calculate the attack rate. You look at those issues. If it's among female and female, you look at the total number of male or male, yeah, the number of male who are affected over the total number of male in that population, and compare with the attack rate among females, the total number of female infected over the total number of female at that particular time. Okay, so after you define uh, the characteristics of people, we said you need to develop now an hypothesis. So how do you define this hypothesis? You can do literature review. Okay, maybe for cholera, if there is an outbreak of cholera, you need to read the literature on the causes of cholera and who is affected and everything. So it will tell you the relationship between variable, or it will tell you what variable you have to consider when you are doing an investigation. Okay, so you can also interview people, okay, to help you develop an outbreak. Then you have to compare um, attack rate in exposed with non-exposed people. Like we have saying, we can do an attack rate in children versus adult and male versus female. So this will help you now to develop an hypothesis to look at who is affected and who is not affected, and what are the common things within this population. Okay, mostly when we are doing an outbreak, we are looking at the exposed versus those people who are not exposed to the risk factor. So if it's food poisoning, you need to look at those people who consumed the food versus those people who did not consume the food. Then you determine who is at high risk, okay, depending on the incidence in the exposed people compared to those who are not exposed. So incidence among those people who consumed the food, and the incidence among people who did not consume the food. It will give you a picture of what is happening. Okay, so these are just steps where you have to go. You have to compare the hypothesis with facts. So that is now hypothesis testing. You compare the hypothesis with facts. After you have interviewed people, now the facts will come to compare the statement that you have developed, okay, about the disease. Okay, so this hypothesis testing involves the analytical studies. So after you have developed the hypothesis, you need to test it. So you can test it using the analytical studies, usually using the cohort study and the case control study. What is the difference between cohort study and case control study? You know, what's the difference cohort and case control studies? Madam Manda, what's the difference between cohort and case control study? Anyone to help us?
A cohort study, I think, follows the people over time to see how exposure affects the outcome. And then a case study, this one reports about one person or a small group of people.
Okay, yeah. So usually a cohort study, it goes in the future.
Description.
Okay. Usually a cohort study, it goes in the future, and it looks at the possibility or the probability of developing the outcome, okay, between the people who are exposed and the people who are not exposed. Then the case control study usually goes in the past, okay, goes in the past to look at the probability of being exposed. So in the outbreak investigation, we usually use um, which one do we use? The cohort or the case control study?
Case control.
Why should we use case control?
Because in case control, we already have the outcome. We want to see if that outcome was due to the exposure that we anticipated retrospective.
Yes. So we are looking at the probability of being exposed. So like we are looking, want to look at the probability of being exposed among those people who are sick, the case, and the control, those people who are not sick. So we want to look at what the probability of being exposed to a certain risk factor. Okay, because in outbreak investigation, we are trying to find the risk factor. So we do analytical study, which involves the case control study or retrospective cohort study. Okay, where we need to look back on what has happened for these people to become sick. Okay, so you do a cohort study. So a cohort study usually involves you need to determine the attack rate among exposed group and attack rate among an exposed group. So this one look at who among those people who are sick or who are exposed, how many people are infected. Okay, so the attack rate among exposed group, it will be those people infected, ill people, over the total number of people exposed. And the attack rate among the non-exposed, we look at the number of people who are sick, okay, over the total number of people who are not exposed, okay, among this group. So each group you look at the people. Then the case control, look at the percent of cases exposed among those people who are sick. How many people are exposed? Okay, over the total cases. Then you look at the controls. The control focus the cases of control exposed among those people who are control group. How many people are exposed? Now the control group is a group of people who are not sick. Okay, among these people who are not sick, how many people are exposed to the same risk factor? And among people who are sick, how many of them are exposed to the risk factor? That's what we are trying to look at the case control when you're looking at the case control. Okay, so let's find this one. So you can do a study like this one, and when you look at this one, okay, This study that we have here, um, this is a case control study, okay, which involves food consumed by cases and controls, which was an outbreak of salmonellosis. So we are trying to check which food here uh, is more likely to be the risk factor. Okay, which food is more likely to be the risk factor? Okay, and for the first one, this the parties we found, what was the odd ratio here? 0.5. Okay, so when the odd ratio is 0.5, what does it mean? Hello? You remember the odd ratio? The odd ratio of
Meaning it can't
0.5.
cause a disease.
Sorry?
Meaning it cannot cause any harm. I don't know if I'm correct.
Yes, this one, it shows that this patches is less likely to cause what? To cause salmonellosis. Okay? Same applies to this one, 0.7. It means that it's less likely that it was the cause of disease, this sausage. Then when you look at
Yes.
beef, uh,
It,
the odd ratio is what?
it's one.
Is 1. That means what?
It is more likely to cause salmonellosis.
So the chances are equal. Okay?
Oh yeah.
For those people who are exposed and those people who are not exposed. So the chances are similar. So now they have given you this one which is in red. Okay? We have seen this one which is in red.
Yes.
Yeah, this is the highest um, odd ratio we have here. So this shows that 6.5, the people who ate this food are more likely to get salmonellosis. Okay, so this is just the odd ratio, which is calculated the way we were calculating last time. Okay, if you want, you can calculate the odd ratio for the first one. I just want you now to understand how now we do this one. So for the first one, what do we have here? You have to draw a 2 by 2 table. You form a 2 by 2 table. On top we have the cases and control group, right? Then this side we have exposed and non-exposed. So for the first one, we have the cases. Okay, I don't know what I'm doing here. We have the cases. Among the cases, how many people were exposed? For the first, these parties, how many people were exposed among the cases?
Is it 26?
This is a percent. I
Oh,
get
it's
this is a
11.
percent. Yeah, it's 11.
11.
Yeah, these were exposed. How many people are non-exposed? You subtract
17.
out of 40, 42. The total is 42. So it will give us what?
Oh, okay. It will give us
31.
30.
Yeah. Then you come to the control group. This one. How many people ate the patties?
17.
17. How many people did not eat?
Which is 15. 25.
15. Or 25? How many?
25.
25. Okay. Then now you find um, the odd ratio. How do we calculate the odd ratio?
So I'm behind. How did she get the 25?
25. We have the control